Okay, working through pages 1 and 2 of your final exam study guide. Let's start right at the top with this graph. First, we're asked for the domain, and every time we're asked for a domain, we want to be considering from the left edge of the grid to the right edge, looking for boundaries. We have none. We have a left arrow, we have a right arrow, so we simply go from negative infinity to positive infinity. For the range, we are looking for boundaries from the bottom to the top, and again, we have none, and we have no breaks in the graph, so we are going continuously from negative infinity to positive infinity. The kind of graph that could have restrictions there, if we had a minimum here and it never came back down below it with an arrow, like it just continued on up, then the range would be limited. If we had a graph with an asymptote, like a log graph that has a vertical asymptote, then our domain would be limited. So there's various ways that we could have a boundary, or we could have a turning point that is the bottom of the graph or the top of the graph. But in this case, with the arrows pointing to the edges, we know that we are infinite in both. Okay, relative maximum would be the top of a turning point, so the top of a peak. So that would be right here. And that relative maximum is located at 2, 4. Relative minimum would be the bottom of a peak, so right here, and that's going to be 0, 0. So those get written as coordinates, xy coordinates. And behavior, as x goes to the right, positive infinity, then f of x is either going to be up or down because it's talking about an output. So the right arrow is pointing down, so that's going to negative infinity. And as x goes to the left, so that's the left arrow pointing up, so that's positive infinity. All right, and then there are some where we have an asymptote drawn, and one of those arrows would be pointing toward the line rather than toward negative infinity. So it's not always going to be one of each of these. It just often is. So just be careful about the boundary ones. Okay, increasing intervals. So to do this one, I'd like to just draw in my trend markers. This is marking the direction of the path. And we'll do this all the way through. I'm looking for down arrows and up arrows along this path. Okay, so increasing intervals would be the up arrows. And remember what we did with this. We said that we were going to start at the turning point. So this is one of my boundaries of that increasing interval. And here's the other one. We're going from turning point to turning point, but we are only concerning ourselves with these two x boundaries. Increasing intervals and decreasing intervals are always x only. So this one is at 0, this one is at 2, so I must be going from 0 to 2. Okay, so this is not a coordinate. It's got nothing to do with the y-axis at all. It's just from x equals 0 to x equals 2. Alright, decreasing intervals would be the downward ones, starting over here on the left side at negative infinity. I don't care that the arrow is pointing up. I care that I'm going to the left side. And then the other decreasing interval is going off to the right side. So I have two of them, one from here to here and one from here to here. So we're going to say negative infinity to 0 joined with 2 to infinity. Okay, and then the zeros, we're looking across the x-axis. Any x-intercepts get written down here in coordinate form. So I can have 0, 0. And I can have 3, 0, or you could write them as x equals 0 and 3. They'll appear either way. All right, next section. What are the zeros of the function? So all we do is we let this function equal 0. And we make a solving chart. So x squared equals 0, and x equals 0. 3x minus 4 equals 0, so x would equal 4/3. And x plus 2 equals 0. The exponents don't matter on these, and so x equals negative 2. Alright, so the zeros are, in increasing order, negative 2, 0, and 4/3. Okay, write an equation for a function that has zeros at 4 with multiplicity 2 and negative 3 with multiplicity 1. So I need two factors, one for this 0 and one for this 0. So we'll say the 1 for 4 would have been generated by a factor of x minus 4. So when I set that equal to 0, I'd get 4. Multiplicity 2 simply means it has an exponent of 2. Okay, and then negative 3 would have been generated by a factor of x plus 3. And multiplicity 1, I could write the 1 or not, doesn't really matter. And that's an equation for a function. Now it doesn't say write the equation, that's because you could have a stretch factor here. You could have a multiplied version of one of these, like 2x plus 6 would have also given you negative 3. So it's just a possible equation that has that function, that has those zeros. All right, let's keep on going here. So we're factoring cubes. And the way we factor cubes is we start with the cube root of each part. So cube root of 27 is 3, cube root of x is x. Carry the minus down, cube root of 64 is 4. So the first binomial factor for cubes is always the cube roots. Then what we do is we work off of this first term and this second term. We're no longer concerning ourselves with the beginning, with the original problem. So 3x, and what I'm going to do is square that and put it here. So 3 squared and x squared. It's going to be 9x squared. For the second term, I multiply the two parts of the binomial, and I change the sign from minus to plus. So 12x. And then for the third term, I'm going to take that negative 4 and square it, which is going to make it positive. And then I can always check, just real quick, if I check 3 times 9 is 27, 4 times 16 is 64, so I have those. I also have a whole bunch of canceling. I have a 36 here and a 36 here, so it all checks out. So every time we have cubes, that's what we're going to do. Number 5, hopefully you notice there's a GCF here. 16 and 250 can both divide by 2. You can also take out a factor of x. So that leaves us with 8x cubed plus 125 without an x. So now I have cubes again. All right, keep the 2x in front. First binomial is going to be cube roots 2x plus 5. And then 2x squared would be 4x squared. 2x times 5 is 10, but we're going to make it the opposite sign. And 5 squared is 25. Okay, so there is page 1. Moving on to page 2. Again, solve by factoring, so we're just going to try to get them factored and then make a solving chart to finish it off. So I have 3x squared minus 2x plus 16, so I need to set it up with a 3x and an x. And let's see, as factors of 16 to go here and here. I'm thinking 4 times 4 first. I can always erase it if I need to. Let's look at the outside part here. I have 12 and I have 4. That's actually not going to work to get me to negative 2. So I'm going to back that up. And let's do 8 times 2. Put an 8 here and a 2 here. So the outer product is 6, the inner product is 8. That's going to work as long as the 8 is negative. So there's just a bit of guess and check there. Make a solving chart. 3x minus 8 equals 0. So x is 8/3. X plus 2 equals 0. So x is negative 2. Okay, so putting them in ascending order. Negative 2 and 8/3. All right, number 7. Trinomial, no common factors. So I'm just going to set up a couple binomials. I have x to the 4th, which means I need x squared times x squared. 42 is 6 times 7, and those are 1 apart, so that should work. Let's put a plus 7 and a minus 6, and that way it'll add up to a plus 1x squared. All right, so solving chart is going to say x squared minus 6 equals 0, so x squared equals 6, which means x is plus and minus root 6. No simplification possible. All right, x squared plus 7 equals 0. So x squared equals negative 7. And square rooting a negative involves an I, so plus minus I root 7. All right, on to number 8. We have 4 terms now, so we're going to split the equation in half. factor out the first half with a GCF. Factor out the second half with a GCF. There's a negative in front. Anytime we have a negative right after the divider, we'll use that. Okay, and then the common factor comes out in front. And the rest of the factors make up their own binomial. All right, solving chart to finish it. 2x minus 3 equals 0. And so x is 3/2. I do have to go back and put the set notation for that one. I'll go back to that in a second. X squared minus 16 equals 0. So x squared equals 16, which means x equals plus and minus 4. All right, so x is negative 4, 3/2, and 4. Back up here, it doesn't matter which order I put these in. X is going to equal plus and minus root 6, plus and minus I root 7. All right. Number 9, splitting it in half again. Okay, so GCF here would be x squared, and that leaves me with x plus 2. GCF here is 5, and that leaves me with x plus 2. So it's the same thing. We take out the common factor. We have our leftovers. Solving chart. X plus 2 equals 0, so x equals negative 2. And x squared plus 5 equals 0, so x squared equals negative 5, and x equals plus and minus I root 5. All right, so set notation, negative 2 and plus and minus I root 5. All right, so there is your solve by factoring section. Use synthetic division to divide. All right, so for these we have to set up our L shape and do our synthetic division process. All right, so we're dividing by x minus 2, which means my root here to divide by is positive 2. We want to get all coefficients represented. Nothing got skipped here exponent-wise, so I don't need to worry about any zeros. So we'll go 1, we'll go 5, we'll go negative 7, we'll go 2. And then the algorithm says bring the first number down, multiply by the outer number, add the column, multiply again, add the column, multiply again, add the column. At the end, if you have a number there other than 0, that's your remainder. And the first number here is the coefficient of the first term. We go 1 exponent down. So that will be x squared. This 7 would be for 7x. And this 7 is the constant 7. Plus the remainder, 16 over whatever I divided by, so x minus 2. All right, so that one's done. Okay, number 11, same concept, except this time, when I bring that root down, I do have a missing term. So I have 1 for the x cubed term. I don't have an x squared term, need to hold that spot with a 0. Then I go across with the rest. Okay, same process. Bring the 1 straight down, multiply, add, multiply, add, and multiply. And add one more time. And again, we have a remainder this time. So we're starting with x squared, then minus 5x, then plus 8, and, well, we could do plus negative 8 over x plus 5, or if you wanted to, you could just write a minus there and make it 8. As long as there's a minus one place or the other, just not both. All right, so there is your synthetic division. All right, last thing on this page was remainder theorem. Okay, so we do the same process. We use this number in a synthetic division. And whatever we get at the end, the remainder, is what we'll say f of 5 equals. That's the remainder theorem. And so let's put these in. We have 1, we have negative 13, we have 39, and negative 4. So let's do this quickly. Bring down the 1, multiply the 5, add, multiply, add, and multiply. And then add one last time. This number at the end is what we're looking for. So f of 5 equals negative 9. All right, and that's it for pages 1 and 2.